So this panel, and we don't have a headshot slide with everybody's names and titles. Apologies, you'll just have to sort of follow along. The title here is Innovations in Ocean Technology, Including Emergence of AI. It's sort of an interesting phrasing, right? So it feels like we have to talk about AI if we're talking about tech, but the keyword there is including. So it's not exclusively about AI. That's going to be sort of part of what we talk about, but certainly not everything. But we are definitely going to be talking about innovation, right? And this topic is near and dear to my heart. I've spent my whole career in this space. And these days, I'm very active in impact investing and philanthropy, all aimed at technologies that are good for the ocean, right? And so what we're going to do here, we'll see how well we pull this off. The intention here is we've got 5 great speakers. I've asked each of them to prepare some slides to introduce themselves, tell you a little bit about where they fit and what they think about this topic. Ideally, we'll get through that in sort of the first half hour or so, if everybody keeps it to 5 to 7 minutes. And then we'll go into sort of a Q&A. We'll have a little discussion amongst ourselves, but my commitment to you all is to save some time for you to participate and ask questions as well. So content and then conversation is what we can expect here. And I'm going to propose, if it's okay with my colleagues on the panel, that we simply go from audience side left to right, which hopefully, so we can start with Dwikorita's slides. And if you can hand a mic, we've got handheld mics. Oh, and the clicker. Yep, sorry. Just getting ourselves organized here. Nope. Yep, there we go. So please, just if you can introduce yourselves and tell us your story, and then we'll get this going.
Well, hello. Yes, I'm Dwikorita Karnawati. Actually, I'm the head of the Agency for Meteorology, Climatology, and Geophysics, and also the permanent representative. The Executive Council of the World Meteorological Organization members, and several other things. But basically, we work not only with the technology, but also with the community, with the people. So we are in a passion to apply and further develop the human technology, or the innovation of the integration of socio-cultural and technology innovation. And what I would like, so directly I explain this. So actually, yes, this about, hang on, it doesn't move?
The green button.
Yes, okay, all right, the opposite. Right, I'm from Indonesia, and Indonesia, including the Southeast Asia. Indonesia is in the Southeast Asia, where we are really influenced by ocean. 60% of our region is the ocean, and we are also situated in between two ocean, that Indian Ocean and Pacific Ocean, as well as between 2 continents. So we are really in a situation, it's influenced by the global, regional, and local climate condition. That's why our weather prediction is really dynamic and complex. So we do need to integrate the dynamic of the ocean as well as atmosphere. So that's why we do a joint innovation with the private company to develop the Ina-Chawo. Actually, the original of the, that's the numerical model is the Chawo, but it's together with Indonesia, so we developed that Ina-Chawo. So it is about the integration of the ocean numerical models with the atmospheric and the wave models. Why? Through this development, which also supported by the big data and AI, we could improve the accuracy of our forecasting. So that's why we do some study on that, and it shows the accuracy before our forecasting, it's about 85%, and now it's reached in average is 92%. And through this study, we can see the difference on the top middle. When we simulate the tropical cyclone, the result of the uncoupled model, you can see the circle the wave model, the wave simulation is not as detailed as the coupled model at the bottom. So that's why we now further improve that with the AI and big data. And we know that apart from the enhancement by using AI and big data, there might be some phenomena or interaction which may not yet occur in the past. That's depend on the data that we collect, so like statistical data. So for the case which is beyond the data that we collect, it may not really match. But anyway, we keep improving that. However, again, we have a serious problem. Despite of the technology we innovate through the observation, modeling, and dissemination for the early warning and forecasting, the people that we are serve is not really, may not really understand that, because the technological product seems to be too technical and complicated for the people. So this is another challenge. It's not about the complexity of the environment, not only about the complexity of the weather and climate, but also complexity of the people itself. So that's why the solution that we developed, the human technology that's combining that the local wisdom, we literate, we educate, we work together with the fishermen, because they need to be empowered in order to protect them or to prepare for the safe ocean for them. And we have done that climate climate field school for the fishermen since 2016. And one success story, this community-based solution for the fishermen field school has saved one of the community. This is the alumni of our field school. He saved one community in his village when we have a tropical cyclone. So he learned how to understand the information, because we put in from the technical, we put into the simple figure, so he can easily understood. We put the simple figure in the platform through mobile phone, and he can manage to understand the tropical cyclone several days before. Depend on the model which disseminate, the result of the model which disseminate through the mobile phone. And finally, he managed to save the village after receiving information via WhatsApp group broadcast and through the platform that we disseminate that. So that's all that I would like to highlight. Indeed, technology is very important, innovation is very important, but still we need to address the capacity of the local people, which may not yet really ready to the technology. So the challenge is how to make a simple product despite of very complicated with the high technology. Thank you very much.
Thank you. Nothing like technology saving lives to get us excited and going for benefits of innovation. Thanks. So Harald, pull up Harald's slides.
Yes. Thanks. My name is Harald Frank. I am economist and management consultant and project developer for One Earth, One Ocean. One Earth, One Ocean is a German-based NGO, and we are activists, and most of our activities are in the field of giving awareness to children, environmental education to children, and for sure we are driving about 10 river cleaner projects, mostly in Southeast Asia, and also in Cairo, Egypt, in the Guanabara Bay in Brazil, in Panama, and so on. And this small river cleaner projects, where we collect about 500 kilograms waste per day, bring it in at the sorting tables and bring it back in the recycling loops. This is only, in German you will say, ein Tropfen auf den heißen Stein. It's a drop in the ocean. And so we think about what can we do, what are good ideas, and what are working ideas for scaling of recycling, for ocean plastic, for waste plastics to go ahead. The idea of the sea elephant, this is the ship, what you can see on the slide, is not to go in the garbage patches and hunt single bottles. This makes no sense with big ships. The idea of this ship is going to a location where it's needed and staying there with this floating recycling facility. This is only a floating recycling facility because the idea is we all know that we need circular economy, and the first step in circular economy is that you sort the waste, and then that you separate all these fractions to give them back in the recycling loop. So we have on board a separation. This is a sorting plant, and we know that many plastics, waste plastics, especially packaging plastics, are multi-layer plastics. Not can be mechanical recycled, so we have also a waste-to-energy plant, and this waste-to-energy plant on board is giving the electricity for the plant at all, and we have more electricity than we need, and giving it back to the power grid on land. So we have these two modes, transfer mode. We are going to the location where it's needed. For example, the ship could be needed in that areas where you are coming from. Jakarta, we are driving also a small river cleaner project in Bekasi near Jakarta. And we know the situation in Jakarta. There is no space. You can't go with new plants in the metropolitan area. And the second item is that it's really complicated to make big plants in middle and low income countries because of lack of permits, of complicated processes. So you come with this ship as a turnkey solution, working from the first day. And this is not a flight to the moon, what we have designed. It's the innovation is not the technology itself. The innovation is the combination of technologies that are proven. And so we are really sure that it will work. We have in the moment the proof of concept, and we have the initial design of this sea elephant. We have some letters of intent, and try to make the funding this year, the conversion of this second-hand bulk carrier in the next year, and hopefully we can go ahead in 2027 in operations. This is a 180 meter long repurposed bulk carrier. and we think that we have to invest about 70 million euros in this project. This is inside the ship. As I told, we have the sorting plant at the first section, and in the second section there is a waste to energy with the best available technology in filters, so we have also no pollution from that side. The input is 90% coming plastic waste from land and 10% from the shore. We have calculated it this way because you are not able to find that much plastics in the water, and also the water plastics is sometimes that dirty that you can only burn it or make energy from this. So the output of this 60,000 tons per anno, or 200 tons per day facility, is sorted plastics, PET, HDPE, LDPE, PPPS, and mixed plastics, and for sure glass, metals, electrical energy. And I think this makes a difference, is CO2 avoidance certificates, because we have additionality if we sort and collect additional plastics. The positive contribution to decarbonization should be 84,000 tons per year if we have full capacity. And the idea is to avoid the production of primary plastics. And so you have savings in fossil and you have savings in energy. This is the idea. The baseline scenario is landfill for this plastics. And if you process it with sea elephant operations, you get this approximately of 80,000 greenhouse gas certificates. And just now we are developing exactly this numbers of carbon credits for the voluntary carbon market with a company named South Pole. It's one of the biggest European companies in this field. Okay, that's all from my side.
Great, thank you. Great reminder, right? Innovation can be thinking, not just in technology. So bring the factory on the ship. I love it.
Yes,
because
we have many examples that best practice is bringing it on the ship, and for sure, why not with a recycling plant?
Is the ship close to the port all the time? Or
Yes, it's close to the port. It's moored.
Great, thank you. Well, Roxy, your slides are up. On to you.
Thanks, Justin. Hi all, I'm Roxy Mathew Koll from the Indian Institute of Tropical Meteorology under the Ministry of Earth Sciences in India. I also work closely with the World Climate Research Program and also the Intergovernmental Panel on Climate Change, that is the IPCC. I wanted to give a global perspective, but before I start, I want to quote what one famous person told today. We need a healthy ocean, and for that we need healthy returns as well. That was Sid Thurston. Thank you, Sid, in the morning. And how do we make sure that we have healthy returns? And for that we need climate resilience. For our infrastructure, we need early warning systems to make sure that if you have a tropical cyclones, lives and property are saved, like what BMKG does. Or if you have ships to manage, you are spending millions of dollars on that. And if you have a storm or extreme event that can affect your operations, or the ship or the property itself, that can be of a huge loss. Or like what Ray was showing today with the blue gold, that's a seaweed. The seaweed has huge potential, but if you are investing on that, and if you cannot monitor and track and forecast these tropical cyclones or other events, weather events, that could be a huge loss, because your operations are based on these weather events, and these weather events are moving. For example, 2015, I remember one of the slides shows 2015 there was 60% reduction. And that could be due to the El Nino factor, which resulted in marine heat waves and so on. And these are weather and climate systems which can be monitored very closely, and the information disseminated to these kind of operations, which can give you value of return. Yeah, and what I have understood is that for every $1 spent on these kind of early warning systems and climate resilience can give you a return of up to $5 to $10 in return. This could be from avoided losses or economic profits and so on, including lives that we save. Yeah. So here I would quickly go on how these weather and climate events are changing. And it's not just about having autonomous vehicles, being in the right place, but also in the right time that you require. We have a lot of ocean observing system. In fact, I have been dealing with Indian Ocean observing system, which is a network of sustained observing systems in the Indian Ocean. It connects with the Pacific as well. Pacific, similarly, we have other networks called TPOS and so on. And similarly in the Atlantic. But these stay in one place. Yeah? But we have weather systems like tropical cyclones, Madden-Julian oscillation. I will give an example anyway. Let me move on to the next slide. And many of these weather systems that we see across the globe source their energy and moisture from the oceans. Yeah? We have marine heat waves, and these oceans are warming rapidly. Heat waves are happening in the ocean also. Marine heat waves are intensifying by 50% in the recent period, in the last 2 or 3 decades. Stronger, wetter hurricanes. So in some regions, hurricanes may not be intensifying, but the amount of rain and the water that they are bringing are increasing because there is more moisture available. Yeah? And another factor is the MJO, which I have been studying closely. MJO, or the Madden-Julian oscillation, are kind of coupled cloud bands originating from the Indian Ocean, and they travel eastward to the maritime continent where we have the Indonesian seas, and some of them cross to the Pacific as well, and sometimes they impact the United States also. Yeah. So we see all these kind of extreme weather events originating from the ocean, impacting across the globe, and they are intensifying as well. So cyclones or hurricanes, extreme rainfall, droughts, marine heat waves, tidal flooding, wave-induced flooding, snowstorms, and all these, some of these are overlapping with each other. So there is a sea level rise, cyclonic or hurricane storm surges happening, and on top of that, the same hurricanes are bringing rains also. So the coastal flooding is, in fact, increasing year by year, decade by decade. And we need to not only monitor them at a stationary base, but also we need to follow these events as well. So this is a perfect example. This is a satellite image. So to orient you, this is the Pacific. You have on the west, we have the maritime continent from where BMKG is, Indonesia is. And if you go further western, it's not in the picture, we have the Indian Ocean. So the cloud bands that start in the Indian Ocean on the far west, yeah, they start with disturbances in the ocean, convection is happening, they move to the maritime continent. And then what happens? Some of them get picked up by jet flows or upper level jet atmospheric rivers across the Pacific, move over the Hawaii, which is why it's called the Pineapple Express, and take that moisture all across to the northern America, including the west coast of US. Yeah? Which means we need to, if we want to understand something in the United States, some weather events in the United States, we might need to understand the entire global dynamics. We need to monitor these events. Yeah? So what happens in the Indian Ocean, this rapid warming doesn't stay in the Indian Ocean, it goes across the globe. And it has impacts, as you see in the bottom figure. This is a study from which we publish in Nature. You can see the changes in the Indo-Pacific warming has impacted in changes in rainfall patterns across the globe, leading into those yellow and blue spots, which means some regions we have increasing rainfall. Some regions reduce rainfall and moisture. For West Coast, it can mean wildfires, California, yeah. And how do we go about it? One of the best ways, we already have networks of stationary monitoring systems, but we need to follow these events, track these events as they develop. And a lot of private sector, private companies have come up with different kind of monitoring systems, uncrewed surface vehicle and subsurface vehicles like this, like sailboys or gliders or autonauts or sail drones, yeah. And you can see the kind of time scale and region that they can monitor. Most of this can span large region. They can move from one South Atlantic to North Atlantic and spend almost 2 years. Sail drone is a perfect example which can track tropical cyclones. Yeah, but many of these efforts are scattered across different private organizations across the globe. Government organizations or agencies, like even NOAA, they work with sail drone company, but they do not produce, have their own products of sail drones. BMKG or IITM do not have these instruments. And the observing system networks also do not necessarily include these kind of unmanned crewed vehicles. So there are a lot of data gaps due to this. There are funding issues. There are gaps in public-private partnerships which we need to work on, operational limits. Some of them cannot operate in exclusive economic zones which have been set by some countries. So we need to crack all this. And we also can use AI so that as the system develop, as the weather system develop, whether it's an MJO or a hurricane or a tropical cyclone, it has that information to follow that weather system there itself and follow that path so that we know the exact track, maybe in Indonesia, where exactly it will hit. So that is important. And for all this is my last slide. For all this, we need regional partnerships. One country alone cannot do that. And we realize that with the current development in the US, with NOAA cutting off a lot of its resources for the globe, and it will affect not just US, but also India, but also Indonesia, because global observations are required to go into these models. And this modeling also is a global effort where all countries work together. Oh, my slide has gone. Okay, perfect. My time is up. Yeah. Oh, perfect. Yeah. So this is one second. This is a beautiful picture which shows on an Indian ship a NOAA mooring or NOAA buoy which is being deployed in the Indian Ocean to study these kind of weather systems. Yeah, and you're all welcome to join us. We have some research students, some people. I work with different networks so that we can put it all together to understand, so that we have a blue economy, so that our systems are climate resilient. We have early warning systems so that the seaweed project or the plastic project or the forecast for saving lives are give us returns in lives in forward to a blue economy. Thank you very much.
Thanks, Roxy, and a great reminder that it's a global interconnected system, right? And innovations can appear and contribute everywhere. So now we can go to Ray's slides that are there and there.
Well, actually, this is the wrong slide set. This is for the other, the other. Do you have I have like 4 different slide files. It's a very short one.
Ray's popular this week.
If they can find it. A little bit of background. I've been a scientist at Woods Hole for well over 40 years. I'm emeritus now. But as a kid, I was very hands-on, tech-oriented. I played around with Heathkit vacuum tube systems back in the 60s. I was very excited when the microprocessor came along when I was in graduate school. And So I've played around with technology quite a bit, and I work with Neil Brown on salinity sensors, and the. Oh, sorry, sure, and it. But I'm also doing a lot of research, and I'm particularly interested in the variations of salinity in the global ocean, and which are driven by the water cycle. It gets fresher when it rains, and it gets saltier when it evaporates. So I realized, by the 90s, during the WOS experiment at Woods Hole and other places, we had developed profiling float technology. And the initial proposal was to monitor the ocean temperature profile with these profiling floats. So they're sort of like weather balloons for the ocean. So my contribution was to insist that we do salinity at the same time. I deployed the first salinity profiling floats in the Atlantic. If you look at the history of the Argo float program, you'll find my name in the history section there, along with Dean Remick. And if we find the right slide, let me see, I might help them get here.
So the title of the slide should be Schmitt Ocean Technology Panel.
Anyway, I just have a picture of the 4,000 Argo floats around the global ocean. And no, okay, that's all right. You've probably all seen the Argo float program. So 20 years on, 25 years on, we now have a really good observing system for ocean salinity. From 06 to 16, I worked with NASA as they put up 2 salinity sensing satellites. So the Argo floats were really great for getting the ground truth and calibrating the salinity satellites, Aquarius and SMAP. And so by the mid-teens, we had a really solid observing system for ocean salinity. And in the back of my mind, ever since the 93 floods on the Mississippi that produced a big pulse of fresh water in the Gulf and into the Gulf Stream, I've had it in mind that if there's a lot of evaporation from the ocean, it's going to make it saltier, and that water is going to end up on land. Some of it's going to end up on land. And so we were looking into the predictability of the possibility of using ocean salinity surface variations to predict rainfall on land. Well, it turns out it works really well. We were able to publish a bunch of papers in 16, 17, even a couple of years ago. We continued to develop the research. In 2016, I found out about a rainfall forecasting contest from the Bureau of Reclamation to forecast rainfall in the U.S. West at 3 and 4 week lead, 5 and 6 week lead. And I entered it with my sons. They were identical twin engineers and expert in machine learning. I'm not an expert in machine learning, but we used a fully connected neural network with the data that I supplied to them. They built this model. We led the contest from the very beginning. It went on for a whole year. It was a fun horse race to watch. Every 2 weeks, you'd submit 2 new forecasts, and you'd find out how you had done 4 and 6 weeks ahead of time. We walked away with $250,000 and decided to start Salient. So what we're doing at Salient is we built a weather prediction company. We've raised grant money and venture money, and we've built up a really strong team of machine learning experts. We have a good business team, and we're providing a long-range forecast far beyond what NOAA can do. We find we're more reliable than the NOAA forecast. And actually, I'll just mention, the challenge we find, we're doing ensemble forecasts. So we give a probability of rainfall. And we find that there's a reluctance on the consumer to think about probabilities. If you talk to a quant at a hedge fund, they understand it. But a lot of people still want a definite forecast. And that's impossible to do with rainfall. You can say, well, we expect so much rain during a week, we can't tell you whether it's going to rain Wednesday or Thursday. So getting people to think probabilistically about forecast has been a challenge for acceptance. Anyway.
Thanks, Ray. And sorry we missed some of the slides there, but we'll move on to Cooper, and then we'll get into some conversation.
Awesome. Thanks so much. And it's a tough act to follow after, one of the founders of the Argo program, which I can't stress more, like this is such a critical foundation for kind of society. I feel it's totally undervalued, but this is, and it's also a tremendous international collaboration that I think we are at danger of losing some of that. And so I am the founder of Ocean Data Network, which is a startup dedicated to advancing fishing vessel-based ocean observing. But the context in which I am here is as one of the co-chairs of the Fishing Vessel Ocean Observing Network, which is a network within the global ocean observing system. So this is the highest level UN coordinating body for ocean observing, alongside the legends at the Argo program. And so kind of putting a little bit of an AI spin on this conversation, I thought it would be interesting to talk about scalability in ocean observing, because part of my central thesis is that AI is a big data method. I don't think anybody would disagree with that, but that the oceans today are extremely data starved places. Particularly when you're talking about beneath the surface, where the satellites can't observe. And so that means that we need to get way, way more data, and that the costs for getting data need to go way down. Lots of folks, I think, are saying that, fleets of robots, this is going to be the solution. I'm fully on board with that. For many applications, that is the right tool for the job. But we need to think about what is the most scalable solution here. And the two largest cost components of ocean data, number one, the platform, number two, the deployment of that platform. And so if we're able to go along for the ride with the folks that are already out at sea every day, we can bring those costs down by orders of magnitude. And it gets even better than that. And so what we're doing is working with fishing vessels, and there are millions operating every day. So let's work with the original maritime industry and get the data. But it's not just, not all ocean data is created equal. It's really, really important to be getting data that's high quality, but also to be getting data where it matters. And so what's really unique about fishing vessel-based ocean obs is the opportunity for the subsurface data collection. So putting sensors like this on a net, trap, hooks, whatever, it's going down, it's fishing, it's getting hauled back up during normal operations. And then as soon as this surfaces, it can offload to a deck hub and then onto the cloud. So that's fully automatic. It doesn't get in the way of fishing at all. So it's tremendously scalable, and we're able to capture that subsurface data component that is so, so challenging with autonomous systems. But then, okay, that makes sense. This is only going to work where fishing takes place, but actually kind of therein lies some of the elegance to this solution, because if you look at the distribution of data today, subsurface data, it's really driven by the Argo coverage. So those are the two maps there. Argo coverage and the other subsurface, that's the blue out there. So out in the open ocean, does a great job. But then in closer to shore, it cannot operate. But then if you look at where we are able to collect with fishing vessels, it's this perfect kind of yin and yang pattern to fill these data gaps. It's really shocking at how well this works, and it complements that system. So, today we're on 600 plus vessels around the world, from Ghana to Greenland, Japan. But we are aiming for tens of thousands of vessels, which would be an absolute paradigm shift in ocean observing and intelligence. And we can go to hundreds of thousands. We are not supply limited at all. And I want to stress, going back to the economic angle, that the coastal data, this is where we need data for the blue economy. This is where the majority of things are happening. And so it's really kind of counterintuitive and strange that we are so data starved in close to shore. A nice example of this is hurricane rapid intensification. Hurricane Harvey slammed into Texas in 2017. it was a tropical cyclone 48 hours before it hit, and then it hit as a category 4. So very, very rapid intensification there. And that rapid intensification, that is driven by the ocean heat, and is very, very challenging to adequately predict, because you need not just the surface, but the temperature down to 100 meters or down to the bottom. And that's exactly what went wrong with the forecasting of Harvey. So that's it from me, and really looking forward to the rest of this discussion.
Yeah, thanks, Cooper. And we'll get into a little conversation here. I want to throw my one, I don't have a slide on this, and I should really write one. When you think about scalability and this idea that innovation, changing the cost, right? You brought up the order of magnitude word, right? And another really important driver, there's been a lot of research discussion here, a lot of environmental. If we just think about energy offshore, if you take an oil rig, and you sort of get a mental picture of an oil rig, that generates a certain amount of energy. And now, picture in your mind a wind farm. To generate the same amount of energy from a wind farm offshore, I've gone back and forth with some folks on this, and our spreadsheets are imperfect, but you need somewhere between 1,000 and 1,500 turbines, right? So you very rapidly are envisioning a single thing, which is big and impressive, in the ocean, to 1,000 things. And so what's happening is the surface area, the water surface, the seafloor area, and the water column volume is scaling massively. Why does that matter as an innovation driver? Well, because the amount of energy produced is the same, the budget for all of the things you need to do, environmental monitoring for compliance, inspection, maintenance, and repair to keep the systems functioning, the budget for those functions will not scale because the energy is the same, or you're going to have to pay a lot more for the energy. So innovators have to come up with ways to change how we do business in the ocean, conceivably by a factor of 1,000. And that's in the economic outcomes, right? There's lots of, we're not going to dig into technical, but just think about, that's another one of these drivers of scalability, right? And I appreciate that Cooper brought that in. So a quick also reminder, right? So this has been a great conversation from global perspectives. We've got the challenge of bringing innovation to human value. We've got creative thinking of bringing the recycling factory to the problem instead of building a new one. You know, a great conversation about how the ocean is a global system and new tools can help us better understand in one part of the world what's going to happen in another. Ray's got a great story of how some core science led to a really creative entrepreneurial outcome. And Cooper as well is connecting a core activity, right, fishing, to another core activity of data collection, right? And so that's all innovation, right? And so the quick question I want to start with, and I'm going to ask all the panelists to comment on, and then I'm going to flip it to you because I'm watching the timer and I'll make sure you all get a chance to speak. But innovation's exciting, right? And it brings opportunity, and it can be very difficult, and it can be challenging. So I'd like to ask each of you to comment on either an opportunity you are excited about, that innovation is empowering in your use case, or a challenge you are facing and something you're having a hard time overcoming where maybe an innovation will help. So giving you the choice, you can talk about a problem or you can talk about a solution, but tell us about, beyond what you've told us, what else is exciting you in your circumstance for the role of innovation and tech in the ocean. And we can start all the way back on the right where we started if we want, or anybody can just chime in. Go ahead, Harald.
Okay. The most challenging for us is, I think, the lack of funding. We have the problem is in this development that we need impact investment. And if we speak with investors, they have a short run perspective, and we need in all these environmental items, we need the long view, and this is a big difference in interests, in making profits, because we want a sustainable world for our grandchild, and so we can't calculate on 3 to 5 years. This makes no sense. And if we got this impact investors, I think we can go ahead. But this is a different thinking on investing.
Could you just elaborate a tiny bit so that if you've been following the ocean track, we talked about this a little bit yesterday too. Timescales are often different, right? You know, certainly consumer electronics, software service businesses move on whole different timescales. When you talk about the impact investing, could you comment a little bit about sort of the timescale you're thinking of, the quantums of cash that you think might make a difference, and maybe a little bit about, is that charitable or is it just a different frame set on returns, right? Can we make this purely, like, can we satisfy capitalists but also do some good if we just change our thinking?
Yeah, we all know that we have to make business, so we can't get it for free. But if we can calculate about 20 years and reduce the expectation in the profit and bottom line, so I think by interest rates of 1 to 1.5%, many things will work. And for our ship, one of the most important things is that we can reduce the invest risk because we are mobile. If we get any problems at the location, because we are in regions where we not have overall democratic systems, stable situations in politics, so we can go to another place. So the investment is not lost, and this is, I think, exactly, especially for this project, a good point.
Yeah, thank you. Anybody else wants to chime in? Challenges, opportunities you're seeing?
Can I? Yeah. So I think this is a common problem across the globe, including United States and India as well. We probably need to make the invisible ocean visible. Just like I showed a bit before, if something happens in the Indian Ocean, it can impact the US as well. But many times, generally, whether it is the people on the top or the public as well, may not see the benefits of monitoring the ocean. They think, okay, maybe you just need to work around the coast for, tracking a hurricane or a heat wave or other kind of storms and events. So I think we need more of those partnerships. So I remember a couple of days ago, we had that lunchtime discussion on, I think it was between Tim and the astronaut, I forgot his name. How do you make NOAA or such organizations, NASA, how do you make it, bring it in the highlight and also make sure that people understand the relevance and the returns of these investments in the ocean across the globe? And I feel it's much more important now than ever earlier because of the emerging and increasing challenges across the globe that we see in terms of extreme weather events. Yeah.
Right on. Yeah, go ahead, Ray, and then we'll get to you. Go ahead, Ray.
As a climate scientist, you want to maintain a climate record for as long as possible. Ideally for 100 years or centuries. How do we maintain something like the Argo, Ray, if with a change of political administration they decide not to fund it? These are challenges that I've written a few papers about with Jim Baker and Carl Wunsch. We proposed that some philanthropies could invest in permanent observing systems. That didn't really fly. So when we discovered this predictability in the ocean surface salinity variations, I thought, well, here's a way to prove to society that ocean data from the faraway deep blue ocean is actually useful to society. So I think we have to maintain the close connection of how the ocean influences our weather, the hurricanes and whatnot. We have to keep that foremost in people's minds so that they understand why we need that data.
Yeah, right on. Please.
Well, actually, our responsibility is also providing not only the prediction or forecasting, but also the early warning system. Together with India, we must take care of 25 countries along the Indian Oceans. Yeah.
That's more than half the population.
Yes, indeed. Yeah. But the challenge is, again, if we remind everyone the mandate of the United Nations Secretary General that by the year of 2027, everyone in the earth must be protected by the early warning. Early warning for all, yeah, but that's not completed yet, I guess, because it must be early warning for all and also early action by all. Regarding with this discussion here, several challenges exist. So you mentioned collaboration, indeed, yeah. So for me, I think it is a little bit pessimistic by 2027. Early warning for all, maybe, yes. What about the early action by all? So that's why the community, society must be always being addressed, whatever innovation we are going to develop. And again, must be a joint development, collaborative development. So I think this is the time for us to remind each other. Otherwise, early warning for all, early action by all may not be successful. So that's why let's work together. Thank you.
Thanks. Any quick thoughts, Cooper?
Yeah, so I mean, I think a key limitation here is, the innovation timescales that governments, multilateral organizations, scientists are engaging in compared with the private sector. And, we need to move really, really fast. But I want to spin that into a positive. And, I am more excited than I ever have been by some recent innovations at the WMO level, GOOS, this Coast Predict Adaptation Fund. There is a lot of money and a lot of financial innovation coming into this space from the real traditional actors. I'm really excited, and I feel like the scientific and the multilateral community is kind of stepping up to this challenge in a way that has surpassed my expectations.
I would just quickly add that many of these resources are already available. We need to make it accessible and visible. Yeah.
And I realize my watch and the timer are out of alignment. So we're going to go, if you bear with us for a couple of minutes, but particularly to make sure that if there's a burning question or two in the audience that anyone would like to present, this is a good time. It's not required, but it's welcome. Yep, please. They got a microphone coming for you.
I'm not an expert in any of these arenas. I happen to be an architect, and because of my grandsons, I got involved in the climate about 6 years ago. And what I discovered was I was amazed at how many active groups and organizations were working on it. And not long into it, I realized that there was a lack of alignment. And as I listened to you, listen to your issues that are there and present, it's like that lack of alignment. And we did an event in Central New York called Breakthrough Central New York, where we started conversations for alignment for the future, one that would empower all of us. Central New York has transformed. It's unbelievable. And it all started with the conversations, and the alignment was led by an Australian gentleman. He currently handles Future IQ, which builds on alignment around the world in different organizations. But he did something that reminds me of the globe. And he drew two circles. He says there are two types of communities. One that is thriving and one that is going the other way. There is no stagnation in the universe. And he started drawing all the different groups that were working towards a better community. And as he drew them around that globe, you could see that the community was not going anywhere because they were working a little bit different all the time. And if I was to offer anything up, is not that I have a solution. I continue to dwell into this inquiry, but I think it's important that minds like yours start to look at how do we create a vision and a goal that we can all align on so that we are as powerful as we are individually. create a synergistic enterprise that works for all of us? I have no answer, but I've been living in this question for over 5 years now, and I offer it up to you as partners in a commitment to future generations that will flourish on this planet. It's time for a transformational breakthrough, and I'm all on board with it. God bless us all.
I'll actually, not to, again, just looking at the time and apologies, I do think there is a break coming up. And my observation on that is for those of us who are in this community, right? So there's been some jargon, there's been acronyms have come up and some things that those of us who know that language, I think there's more certainly philosophical alignment. And then when you hear about the challenges of whether it's funding, timelines, or public buy-in, right? I think what you're observing is a small collegial community that shares a lot of values and objectives, struggling to get that alignment with the rest of a planetary community that doesn't necessarily have the understanding. And so I think that's why, frankly, I'll just sort of say, here's my little shout out to EarthX, right? It's been great to bring our little ocean community here and start working on those conversations. So I'm gonna just call this, right? So we are eating into the break, and I think it's probably, I can see some enthusiasm. So I'll go grab coffee and talk amongst yourselves, and let's start solving those problems with some real action. So does that sound fair? What you tell us what to do next, Tracy?
Yeah, that sounds great.
When are we come back? Sorry.
We are coming back at 3:15. 3:15.
All right. Thank you,
Right back
panelists.
here.
Thank you, everyone, for your time.
Everybody do some jumping jacks. Get re-energized.